Hello, this is a lesson day 3 of rational functions, section 4.2. In our previous lessons, we had talked about asymptotes, vertical, horizontal, and oblique. Today, we're going to talk about a special case where it is not a vertical asymptote, but it is a hole. They can be confusing between the two, so really make sure you understand it before the end of this lesson. Now, before we do that, I want to review some factoring in some special cases. Now, when we talk about squares, it's to the second power. These are some special cases. It's when there's no middle term. For the top one, it is a square root of each of the two terms, and then you have a plus and then a minus. This one is not factorable when you have a plus in between. It just isn't. So when we talk about, that's interesting. I'll tell you in a moment. Cubic, it's to the third power. I just noticed it was lowercase. I'm not sure how it turned uppercase, but it should be a lowercase a. Sorry about that. It's so weird. So it should be that. There is just the special case, and this is what happens. And if you factor it, it's this. Now, that hopefully you have seen this before. I don't know if you have. But if you multiply it out like this and this, it comes out to that. So it looks really weird that all these things, when you multiply it, all disappear and just simplify to this very neat, small polynomial. So when you have this, you have to take the cube root of a and cube root of b. So finding that is the most important thing. And once you do it, you just put it into this formula. So it's a plus b times, don't forget the parentheses, a squared minus. So it's the opposite sign of what is given. Here it's the same, right? And then here's opposite. And then this one is always addition. So if we look at the next one, the minus, right? So here, the first one's the same sign, and then this is the opposite sign, and then this is addition. So this last sign will always be addition. Okay. So let's try a couple problems. So how do I know that it is a cubic? Well, I only have two terms. The first one clearly is a cube because you can see cube. And I can take the cube root of that and it'd be a nice integer. So the cube root of x cubed is x, so that's my a. Remember, the first thing you have to do is find a and b. And then the cube root of 8 is 2. Once you find that, then you just put it in. Now it's plus, so I'm going to use this top one. So it says a plus b, so it's x plus 2. A squared, that's going to be x squared, minus a times b, which is, and don't write x2. If you write this, we know better, right? The 2 is going to go first, so this is 2x. And b squared, don't write 2 squared. Please, 2 times 2 is 4. Like, just multiply it out. And then that's it. Remember, it's factoring. If you multiply it again, it's just going to get here. And then you just ended up, you go back to where you began. So remember, factoring, you want those nice parentheses. All right, so this next one, again, I have to find a and b. So taking the cube root of that, that's x. The cube root of this, okay, so you're saying, Miss Mendoza, what about that negative? We ignore the negative. It's just the number. Just take the number 27 and cube that, right? So that's going to be 3. So what we have here is the second one, right? So it's going to stay a minus, so it's a minus b. So again, so we want it to be the same sign. a squared times a and b, and it's always plus. So it's 3x and then b squared, which is 9. Remember, always simplify. There you are. So let's go to our special case, vertical asymptotes revisited. Okay. So if we're looking here, generally the vertical asymptote, I would say let's factor the denominator and find the domain first. So I'm going to factor the denominator, and factors of 27, 7 and 3, positive and negative. Okay. Then I would say that the domain is all real numbers except x can't be 7 and x can't be 3, right? That's true. And generally, I would say, okay, the vertical asymptote would be x equals -7 and x equals 3. However, this is not true. What you have to do is look in the numerator. So you have to say, okay, is there anything I can do there? Can I factor that? Yes. So you're going to factor this, and you're going to rewrite your factors on top of each other. So now I'm going to write it like this. What do you see? What do you notice? I notice that the x minus 3 is the same as numerator and denominator. And we should know, as I just said not too long ago, we simplify everything. So what happens is that simplifies out. So really your new function, what it simplifies to is right? You're like, oh, so what does that mean? Well, that means that this is your whole. You're like, what does a whole mean, Miss Mendoza? I'll tell you in a moment graphically. So it's not a vertical asymptote, it's a whole. So what do you have to say? So you have to say, okay, that, Miss Mendoza, is a whole. Okay, whole. Does it change the domain? No, it doesn't. Domain is same. Okay, so we write this, whole at x equals 3. And you're like, okay. So this is what happens. Let us look at the other asymptote so we can draw. So is there oblique or is it horizontal? So if we're looking at the degree, right, of the numerator and denominator, the n, which is 2, and the m, which is 2, they are equal. So when they are equal, then it's the a and b, it's the coefficient, which is 1. So it's a horizontal asymptote at y equals 1. Okay. And I'm going to graph it. Now, we haven't done graphing before. This should make sense to us since we know what these lines are. X equals -7. 1, 2, 3, 4, 5, 6, 7. And yes, you have to label it. And doing a dotted line. Cannot cross that. All right. And then I'm going to take my horizontal, which is y equals 1, which we should know what that looks like. And I'm going to go this way. Okay. I'm going to find my y-intercept. You're like, why? Because I need a point. So f of 0, and I'm going to use this, is going to be 3/7, which is less than 1, which is under here. All right. So now I have a whole at x equals 3, which is over here, 1, 2, 3. So it looks like this. Because I know this is an x-intercept, or y-intercept, sorry. My graph is going to go look this way, and then it's going to go down, and it's going to come up. And it's going to keep going until we hit 3. Well, guess what happens at 3? It's not a line, it's a hole. It's like, you know what a sinkhole is? It's like the road is going, it's going. Then there's this big hole in the ground, literally. And then you have to jump over it and keep going at the other side, right? That is your hole. Do you see it's not an asymptote? It's not an asymptote because asymptote, remember, is a line that the function gets really, really close to, right? It approaches it. So we can see here how it gets really snug, it gets really close. But in the hole, it doesn't approach it. It had a vertical asymptote. If there was a vertical asymptote, it would have to go up like that or down that way, and it doesn't. So a hole is just a hole that does not continue, that does not just wrap the way the road is going or the function is moving. It's still going this way. It didn't change directions. It just has a hole. Kind of has to jump over it and then keep going, right? So hole, not an asymptote. It's where you can cancel out or simplify out a factor in the numerator and the denominator. All right, so let's practice. So the direction says find all the asymptotes. All right, so have to make sure all the asymptotes tend to find the vertical ones first. So I'm looking, and so we either have vertical, we're going to have a vertical and maybe. So I'm looking here, can I factor it? The answer is yes. And we talked about earlier about the special case with squares, and this is a special case because you have two terms and then you have that minus in between. So you take the square root of both. So square root of 9 is 3. Square root of x squared is x. So this is also 3x. 3x times 3x is 9x squared. And then square root of 4, which is 2 and 2. And the minus tells me plus minus. So my domain would be all real numbers except x can't be negative 2 over 3 and positive 2. X can't be, sorry about that, positive 2 over 3. So the vertical asymptotes, let's look. Can I factor out anything in the numerator? Nope. Numerator is okay. All right. So my vertical asymptotes are x equals negative 2/3 and x equals positive 2/3. Is it a horizontal or an oblique? Well, let's see. My degree is 1 over 2. So n1, right, is less than 2. So n is less than m. That tells me that it is a horizontal asymptote, and y equals 0. Okay. And oblique asymptote is none, and it has no holes. Okay. Remember, it can have either horizontal or oblique. It doesn't have one, but it doesn't have both. All right, so if we're looking at this one, clearly there are things to be factored. So I'm going to look in the bottom, and I'm going to see, all right, factor, x, factors of 48 with 2, that's separate by 2. That is 8 and 6. Plus, minus. All right, what about above? Now, because I'm going to have to, again, check for holes, so you're going to have to check the numerator. This will also later help you to find that x-intercepts. So when you do this, I'm going to say the factors of 2x are 2x and x. The factors of 8 are 1 and 8, okay, or 2 and 4. Now, I know, just looking at that, does everyone see that 2 times 8 is 16 and plus 1 is 17? So what if I literally just wrote it like that? What if I put the 8 here? And I know it's plus plus, and put a 1. So if I have here, that's 16x. And here is 1x. Does that give me 17x? Yes, it does. Perfect. Nice factoring. All right, so my domain, and you're like, Miss Mendoza, do I have to find the domain? No, but it's really, really good practice. And again, so you know the difference between domain, vertical asymptote. All right, so the domains, you see I didn't change it. It's still that. Because in our next lessons, we're going to be graphing. So it's really good just to have this all set up because you're going to need the domain. So when you have that, let's look. Vertical asymptotes. Is there anything I can cancel? Yes. So I only have one left. So it's x equals 6. So what does that tell me? Well, it tells me that there's a hole. Now you don't have to write this because the direction says find all the asymptotes, but just good habit. Hole at. That means at, right? At x negative 8. All right. Horizontal or oblique? Well, m and n, let's look at the degrees. They're equal this time, right? So that's a horizontal. Again, look at your notes at all the 4 cases. And therefore, it is that coefficient over this coefficient, which is 1. So it is 2 over 1, which just simplifies to y equals 2. Horizontal asymptote, therefore there are no obliques. None. All right, there you are. Don't forget to answer the EQ. Bye.